Virtual reality can be a powerful tool which companies can use to promote, advertise, or raise awareness of their own business. In the past 2 to 3 years, we have seen an explosion of interest in this technology in a growing number of industries, such as the automotive industry, entertainment, and architecture. And these industries have benefited greatly by allowing users to immerse themselves in a virtual environment. Currently, there are two distinct ways of creating VR experiences for industry. The first is a bespoke experience using assets and environments specifically created by designers, along with tailor-made functionality created by a games developer for use within a game engine such as Unity or Unreal. The second is an integrated VR experience, normally in the form of a plugin within a 3D application such as Revit or SketchUp. Virtual reality is a very demanding visual output, mainly because of the amount of screen space and resolution that needs rendered within the virtual reality headset, as well as having a recommended frame rate of around 90 FPS. As a result of this, designers and developers need to pay special attention to the content displayed to the user. The performance limit can, to a certain extent, be offset by using more powerful hardware, but merely brute forcing our way through is not an ideal option. These performance considerations should not be ignored though, as doing so can lead to poor user experience and even physical discomfort for the user if the frame rate drops too low. This is especially important when importing already existing CAD models to be used in a VR environment, as they are often very detailed. Today we are discussing specifically high-end VR, which requires a powerful PC and a high-end consumer VR headset system such as the HTC Vive or Oculus Rift, and a game engine used for the visualization such as Unity 3D or Unreal Engine. First of all, we will look at the workflow required to bring industry standard 3D models such as CAD models with the end goal of a game engine VR experience. The first stage we need to look at is planning. Planning the wanted features and the scope of the VR environment is a necessary step, as it will lay the groundwork for the future steps. These are some aspects we may wish to consider. What platform will be used? Where can the user go? And what can the user see? What are the interactions? And what will the model look like? In the end, it all boils down to the complexity and scope of the model. The larger the model or environment, the less details we can cram into that space. On the other hand, a model of a single product can most likely be used as it is, requiring little or no preparation work to be brought into the game engine. We will now look at the steps required for bringing a CAD model to be used in a game engine. Removing unnecessary parts and cleanup. We only want to include the features of a model that are actually needed. This means objects or parts outside of the area of interest, as well as parts that will be completely hidden inside or obstructed by other objects. CAD models often include the internal components and mechanisms involved, so unless it is planned that the user will interact with them in some manner, they should be left out. If possible, this should be done already in the CAD application, as when exporting, depending on the software and file formats used, some of the structure of the model may be lost. This will make it easier to work on the model further down the pipeline and helps keep the file size down. We also have to make sure that there are no overlapping surfaces in the model, as these will otherwise need to be cleaned up later. Make sure the parts are laid out in a logical fashion. So for example, a single ball segment doesn't consist of a dozen small parts unless they are clearly separate pieces. Avoid merging everything into a single giant chunk though. Exporting the model. CAD models are parametric by nature, but to be used in a game engine, they need to be converted to a polygonal mesh format. Depending on the software, There should usually be a setting to adjust the resolution of the exported mesh. The resolution used will again depend on the complexity of the model and software used, but it's often best not to go too low as it may introduce distortion into the model. It is also easier to reduce details later than try to salvage a too low resolution mesh. Picking a file format for the export is largely a matter of preference and should be communicated with the person responsible for working with the model further down the pipeline. A generic polygonal mesh format such as STL, OBJ, or FBX is usually a safe choice. If for some reason these formats are not available, a well-supported CAD format such as IGES or STEP is the next best option, meaning the conversion to mesh will be handled later on. If there are surface textures used with the materials, these are usually lost when exporting and should be delivered separately. Material setup usually carries over, so it is recommended to set up the material definitions before exporting if they are relevant. Preparing the model for game engine usage. For a quick solution, using a model directly exported to a mesh format can be used in a game engine, but it will usually be imported into a software more suited to polygonal mesh modeling, such as Maya or Blender, for additional tweaking and making sure everything is working as intended. The model will be optimized by simplifying too dense geometry and is checked for any possible problems such as overlapping surfaces, errors with surface normals, or smoothing information. Possible additional tasks carried out in this step are animating moving parts or creating and cleaning up the UV layout to make sure the possible surface textures are displayed correctly. It is recommended to test the model in the VR environment early on before delving too deep into optimization to see how the model performs and to see which parts may require further editing. Any major flaws with the model should be addressed here before continuing further. Smaller problems can be fixed by remodeling the problematic parts by hand, but it should not be the default option to make everything twice. We can take exception to mobile development, as due to the performance limitations, it can actually be faster to model some parts by hand based on the CAD geometry, as automatic decimation tools can sometimes fail with very complex geometry. Here we can see a side-by-side comparison of a model part that was imported from a CAD software without any optimization, and after some automatic optimization work in a modeling application. Even for a small part like this, the geometry is nearly 70% lighter. The benefit gained from optimizing the models depends heavily on the shape, but the example illustrates just how beneficial even a quick optimization pass can be. The gain could easily be tenfold or more if the original object had some hidden internal parts that would have been removed. Spread over possibly hundreds of objects in a larger scene, this difference does add up and can mean the difference between a great experience and not being able to run the scene in VR at the required frame rate. Engine-specific steps. The optimized model will be brought into the game engine of choice by exporting it to an intermediary format supported by the engine, such as FBX or OBJ. Depending on the scenario, a lot will happen inside the game engine itself, as it will be responsible for rendering the scene and handling the user interactions. This is also the step where some of the less obvious parts that need tweaking will be spotted as all the interactions are put together, and should be fixed by backtracking to the previous step. Some of the typical things that happen in engine are setting up the scene and collision geometries, adding geometries and applying surface materials, creating and applying animations, programming interactions and adding VR functionality, adding the user interface, testing and debugging, and compiling the final application. As there are a lot of variables involved when bringing a CAD model to a VR environment, sometimes things require a bit of experimentation to work. Here are a few general tips that might prove helpful. Consult the person responsible for working with the game engine for any specific needs before preparing for exporting the model. If the model has a lot of errors or missing parts, try a different file format or adjust the mesh resolution settings higher. Although generic 3D formats are a safe bet, sometimes there are compatibility issues with certain software and certain formats. Test in VR as early as possible. Getting to view the model in real scale and in the right environment is a great way to spot issues that might otherwise be left unnoticed. There is a global trend with major CAD software companies towards integrating VR as part of the design or modeling process. But for custom interactions and graphically intense real-time applications, game engines are the way to go.